All right. So now you discovered. Oh, what's going on here, friend? Okay, you discovered your 10 cup coffee condition in the previous problem was bogus, bad data, data entry error. Run the 2 by 2 ANOVA from the data above. This is 2 by 2 between. This is the exact same data I had before. HIJKL. All right. Bye bye bye. This data goes bye bye. Um, I'm gonna restart all of this just to show you. Remove. That you could do it a quicker way. You could just kind of like leave it up and do the analysis, but let's just do it again. Click the ANOVA. I hate that it holds all my previous sort of options up. Okay, but meditation, coffee intake, happiness. This is a 2 by 2 ANOVA where it was a 3 by 2 ANOVA. So I like these a lot because really, this one's super nice because we don't have an interaction. We don't have one of the main effects, and we only have a significant main effect. Like, so what? But that's okay. We still got to do some stuff. We need our partial etas. I got that as well. Um, if we're doing this one, I kind of, didn't put all those instructions in there, so I don't have to write it out because I think you know how to do it. We just wrote one out. But essentially, in a 2 by 2 by 2, you don't really need post hocs. Now they're going to help. They're going to help us in one specific way because for our main effects, we can get the Cohen's d and 95% confidence interval with Cohen's d. But I want to do this step by step. So let's look at meditation here. It's the same data, so there's a lot of things we know, but I want to do it the right way for you. So I have my meditation means meditation improves happiness relative to no meditation. This main effect is a significant main effect in the ANOVA with an F of 64 and a P of less than 0.001. It has 1 in 8 degrees of freedom. And the 95% confidence interval, wait, let me see here. Cohen's d, 95% confidence interval of Cohen's d. The Cohen's d is 4.61 with 1.64 and 7.60 has the 95% confidence interval. So let's just talk about this. What do we know? It is significant, right? We know before that meditation improves happiness. This is a significant effect. We know that the population effect size is between large and large, and that's really it. So everything I just said, we can put into it, but essentially all I'm gonna write now is F with 1 degree of freedom and 8 degrees of freedom. 1 for the main effect of meditation and 8 for the error term equals 64.00. P-value is less than 0.001. The partial eta squared we don't need because we have Cohen's d of 4.62 with a 95% confidence interval of 1.64 and 7.60. So what you're noticing for any of the ANOVA, for any of these factorial ANOVAs that are completely between, you just use Cohen's d as the effect size, which I need to sort of write that in there. D equals, okay. And all my questions, it's significant, right? Meditation improves happiness. That's my headline. It's significant. The population effect size is a large one. It's between large and large. 1.64 is large. 7.60 is large. Yeah, that's all we really need to say for that one. The post hoc test, I'm only using it not for the p-value, just for the Cohen's d. When I look, we know that the next one is not significant, but we still have to treat it with respect. So what I want here is to put coffee intake in here, and just see what I get. Okay, 5 cups is better than 1 cup. We see that. That's great. the main effect of coffee is not significant. So we have a non-significant effect. We have the F statistic is 4 with 1 in 8 degrees of freedom. The p-value is 0.081. And we now need the 95% confidence interval of Cohen's d, which we'll get with the postdocs for coffee intake. So much easier than the 3 level, right? But the one thing that I don't like is that this is in line with my hypothesis. So I go back to my data. I click on my coffee. I move 5 above 1. And you'll see now everything's in line. My t-statistic's positive. The effect was in line with my hypothesis. The effect could be a large effect in the direction I predicted. Well, the effect is the Cohen's d is large in my sample. The effect could be a large effect in the direction I predicted, or it could be a negative small effect, right? So for that, F with 1,8 degrees of freedom equals 4.00, P equals 0.081, D equals 1.16 with 95% confidence interval of negative 0.33 and a positive 2.64. The headline there is we know nothing. That would be our headline because we do know nothing. This could be a small effect in the opposite direction we predicted or a large effect in the direction we predicted. I'm not writing this all out because I've written this one out in the previous one. You can answer the questions. And then finally, our interaction is not significant as well, but we still have to do our work. So I'm going to click in here. I'm going to do what I have to do to make this visible. But the one thing I want to do is I want to remove that from here. And I'm going to stick with my rule. There's only 2 slopes here. So let's see what I'm talking about. This is a 2x2. We did not have a significant interaction. There's no need for follow-up tests, right? But essentially, I'm going to show it to you both ways. The interaction, sorry, I want to have both graphs. When I can, when it's not too overburdened, right? In a 2x2, I like to look at the 2 different ways you can show the interaction graph, right? So in either way, the interaction test tells us that this slope is not significantly different from this slope. That this slope is not significantly different from that slope, right? That's what we know. So we know these 2 slopes aren't different from each other. Well, if we can't prove that these 2 slopes are different in the population, we ran a bad experiment. We know why. We've talked about that one too many times because the null is always logically just wrong. But we're like, okay, what do we need to do? Well, right now, we describe the slopes. Oh, those that meditate did not show a difference in happiness between having 1 and 5 cups of coffee. For those that did not meditate, right, it looks like 5 cups of coffee might be associated with more happiness for those meditators. However, these 2 slopes are not different, so we know nothing, essentially. That's essentially what we know. For here, it's a little bit easier. You're just like, okay, there appears to be a slight increase in happiness for people who drink 5 cups and a slight increase of happiness for people who drink 1 cup. I think I read this wrong. I did, but that's okay. You can see there, like if I'm showing my lack of an interaction, this is the better graph. So you can see that because this one kind of looks like the slopes are different. So I'm going to get rid of it. Not just because I botched the interpretation, but this one fits what I want to say, right? So these 2 slopes look essentially the same. There's a little benefit of meditation. We knew that from the main effect, but there's no special change in that relationship, right? Okay. The one thing I see is that my partial eta squared is 0.33. And now I need to calculate a 90% confidence interval for my eta squared with a between subjects analysis. 8, 9, 10, 11 plus 1 is 12 participants. The degrees of freedom, 1 for my interaction, the degrees of freedom 1 for my interaction term is 1. My degrees of freedom error for my residual term is 8. One, 8. 12 participants. Run my command, get my results here. I'll make it a little bit bigger so we can see. All right. So I'm just going to kind of put this in there. What does this mean? My 90% CI of eta squared is from 0.12, which is a medium effect, to 0.73, which is a large effect. All right. So we have, our interaction was not significant. F with 1 and 8 degrees of freedom equals 4.00. P equals 0.081. D equals, well, not D, sorry, partial eta squared, and I'll fix the subscripts in a second, equals 0.33 with a 90% CI of 0.12 and 0.73. My headline for that one is, there was no interaction. We did not find an interaction, essentially. So, because we didn't find significance, we didn't cross that first hurdle. Even though our partial eta squared seems nice, right? If we can't cross the significance threshold, we still can't trust it, right? Processing data is not always super easy or super perfect, right? But right here we're saying, hey, we didn't find we didn't find anything. It's not significant. We didn't find a significant interaction. Those two slopes are the same. That's essentially what we're saying. These two slopes right here are the same. All right, that might have been a little messy. That's probably my worst video of the evening so far. But those are the right answers. Those are correct enough for me. Every single factorial ANOVA, you're testing 3 effects at the same time. I didn't write everything out. We just did the previous one. Go do the previous one. Go look at that one. But essentially here we have meditation improves happiness. We have an effect where we don't know the true effect of coffee intake on happiness, but it appears that it could be a negative small effect or anything between that and a large positive effect. We need to run a better study to examine that main effect of coffee. For the interaction, we didn't find the significance that we were expecting. The 90% confidence interval of eta squared looks okay, but we still need both to work out. So this is where we're at with that. Just making sure, yep, I was in the right one. So that's 8, 9, 10, 11. Total degrees of freedom is 11. Plus 1 is 12. All right. If this doesn't make sense, reach out to me, but those are the answers. I've given them verbally. We have it.